Okay, I'm going to try to get through this. I've tried this several times, and this is just not being terribly polite to me, but let's see if we can do it. This says the number of diagonals of a polygon with n sides is defined, as you can see, is defined by that formula, n times n minus 3 over 2. Now I'm going to tell you that because it gave you the formula, you actually could take this formula and go straight to your calculator and just type this into your equation editor. So click new, and then you could say, okay, I'm going to open a parenthesis for the whole numerator. I don't think it's typing. Okay, open parenthesis, n times, open parenthesis, n minus 3, close the n minus 3, close the entire numerator, divided by open parenthesis 2, close parenthesis. Parentheses are your friends. So just make sure that if you've got especially numerator and denominator, that you note these both. Now I've intentionally made two different mistakes. The first one is if I click OK, it's going to tell me that it doesn't understand it's an unknown function, and I want you to see why. Even though this formula has n's, I want you to notice that your calculator requires that it be y of x. It just needs an x there, and that's just pre-programmed. It's okay. You're just going to put x's in instead of the n, and then click OK. Now it says unknown function. All right, an unknown function error usually means something's wrong with the operations, and the cursor will go right to it. And the thing is, it's not understanding that the x sitting beside the parenthesis is multiplication, so I'm just going to put times there and then OK. So I had to do a couple of things. I had to change the n to an x, and I had to make sure, because it doesn't understand when the x is sitting by a parenthesis, I had to make sure that I put a times there. Now I'm going to go to the table. Remember, the table defaults to a very small step, but you can't have partial steps when your x, or in this case n, stands for the number of sides. So I changed it to 1. Remember, you have to tab back over to the start to get it to register. But I want you to notice this stands for the number of sides, and this stands for the number of diagonals. And you can see that if you have 14 sides, you've got 77 diagonals. So going back to this problem, here, if a polygon has 77 diagonals, you know then that it has 14 sides. I do want to show you very quickly that you really didn't need it to tell you that, the formula. And in certain situations, they might not tell you the formula, and I want to show you what the solution to that is. If you know the number of sides, you can figure out the number of diagonals without the formula just by starting down at the smallest polygon you know, which is a triangle. And think about it, a triangle, if I draw it over here, there are no diagonals, because connecting one vertex to any other vertex just is a side. So there are no diagonals there. If you had 4 sides, and draw a 4-sided figure, you have 2 diagonals. If you have 5 sides, 5 sides is a pentagon. Here we go, and you've got 1, 2, 3, 4, 5 different diagonals for a pentagon. If you notice, you might actually see the pattern from the diagonals from the first stage to the second went up 2. From the second to the third, it went up 3. And I'm pretty sure it's going to go up 4 to get to a 6-sided figure, but that's small enough for me to draw, so I'm just going to draw a hexagon and then try to imagine how many diagonals there would be. And there would be 1, 2, 3, 4, 5, 6, 7, 8. There are 8. Oh, I've missed one. I have. Oh, right here. 9. Right there. If I draw that a little bigger, and I'm not going to, you'd be able to see that there's a triangle going this way, a triangle going this way, and then an X through the middle. And so 3, well, sort of like a star, 3 coming together, and that's the number of diagonals. So it was 4. So if you wanted to, you could actually have 10, 11, have just gone through here and followed that pattern by adding an additional above plus 1. So this would go up 5. 9 plus 5 is 14. This one would go up 6. So the next one would be 20. It would go up 7 to 27. It would go up 8 to 35. It would go up 9 to 44. It would go up 10 to 54. It would go up 11 to 65. It would go up 12 to 77, and 13 to go up to 80, 90. But we found it right there. So you didn't really need the formula, but it was nice to have. That was number 1. And so that answer, going back, hold on, that answer was 14, which was C.